Hello there and welcome once again to this physics tutorial presented to you by O3 Schools JAMB app. Now, O3 Schools JAMB app is an application which helps you as you study for your JAMB, your UTME examinations. Now, the O3 Schools JAMB app has several features which are all designed towards giving the student, that is you, maximum possible experience such that your learning is faster, it aids your learning. You have situations to practice for your exam, and you will have one of my favorites, the question search feature, in which you can actually search for questions relating to topics within subjects that you've read, such that as you cover a topic while preparing, you can actually go to the app, search out all questions JAMB has set relating to that topic, and then answer them, as this will actually help your reading faster, make it faster and more accurate. Now, without further ado, in this physics class, we shall be looking at gas laws. Now, obviously, we must know first off that matter exists in three states: solid, liquid, and gas. We're going to be focusing on gases in this class. Now, the gas laws are simply the laws that govern the behavior of gases when one or more of their properties gets changed. When one or more property of a gas gets changed, what happens to the other properties? How are they affected by this initial change? That is what we shall be studying in gas laws. Now, the properties we shall be looking at are pressure, volume, and temperature. Now, first off, what is pressure? Pressure is generated by the molecules of the gas hitting the walls of the container. So if you have, say, a container and there are gases within it, these gases are not stationary. Instead, they are always moving. So the forces which they generate hitting these container walls, the force divided by the area of this container gives you the pressure. And the SI unit of pressure is Newton per squared meter. That's pressure. Next up, we have volume. Volume is the amount of space occupied by the gas. That's volume. And the SI unit of volume is meter cube. Though within this topic, we may see it measured in centimeter cube in some instances. Now, you don't always have to convert. You shall be looking at a lot of ratios. All you simply have to make sure is that if there's a ratio involved, that the SI units of both must be the same. So say we're having a ratio V1 over V2. If V1 is a centimeter cube and V2 is a centimeter cube, then there's no reason to convert either. You can simply work with that because the centimeter cube will cancel out. But if they are not, then you have to make sure that they both exist in the same unit. That's that for volume. Then temperature. Temperature, as we know, is, in layman's terms, the degree of hotness or coolness of a body, of a system, or in molecular terms, is a measure of the average kinetic energy of the molecules of a body. Now, temperature has a SI unit of Kelvin. Note a lot of times, temperature will be given to you in degrees Celsius. To convert it to Kelvin, all you have to do is 273 plus the value in degrees Celsius. That will help you get your temperature from degrees Celsius to Kelvin, because we always want it in Kelvin before we can solve. Okay, now once we know these parameters, what are the laws we shall be looking at? There are several gas laws. There is Boyle's law. There is Charles' law. There is Dalton's law, what is also referred to as the pressure law. And those are the three basic laws we shall be looking at in physics. Undoubtedly, if you studied chemistry, gas laws is also there, and there are a couple other laws. But for now, in physics, these are the core ones we focus on. Then obviously, these are not laws, but you must know that there's a general gas equation, and 5, there's the ideal gas equation. So these 5 are the things we are going to be focused on within this topic. So let's start off. We are looking first of all at Boyle's law. Now, what does Boyle's law state? Please keep in mind that each of these laws have parameters to deal with. Boyle's law works on pressure and volume. Charles' law works on volume and temperature. while the pressure law works on pressure and temperature. So in each of these, whatever is not there is being kept constant. In fact, that in Boyle's law, we take the temperature as being constant. In Charles' law, we take the pressure as being constant. And in pressure law, we take the volume as being constant. So once again, what is Boyle's law? Boyle's law simply states that the volume of a gas is inversely proportional to the pressure, provided temperature is kept constant. That volume is inversely proportional to the pressure, provided temperature is constant. Again, this we call this is Boyle's law. Now, this implies quite simply that P equals constant K over V, such that constant K equals to PV. Therefore, the formula simply becomes P1V1 equals P2V2. This is the formula for Boyle's law. It simply indicates that if your pressure is increasing, your volume must decrease. Increasing the pressure on the container increases the volume. And this example is you take a balloon, for example, you pumped it with air, and then you begin to press on the container. You're increasing the pressure on that container, on the balloon. As you press the balloon together, pressure is increasing. However, what happens to the volume? The volume is reducing because you are compressing the balloon. That is simply a statement of Boyle's law. And this is it. Now you must please note that work done is actually equals to P change in V. Therefore, occasionally, we can look at Boyle's law as being a statement of work. So, of all the laws, Boyle's law is the one that deals with work. Okay, that's Boyle's law. And please note the formula. Let's stop. Let me just write the formula down here so can we see it as we move on. P2V2. Next, we're looking at Charles's law. The law created by Charles. Now, Charles' law deals with, as you can see there, volume and temperature. So what does Charles' law state? Charles' law says that the volume of a gas is directly proportional to its temperature. In Kelvin, please note the emphasis. The volume is proportional to the temperature in Kelvin, provided the pressure is kept constant. Therefore, that simply indicates that volume is proportional to temperature. If I introduce a constant, KT, then over T over T, K equals V over T. And therefore, the formula becomes V1 over T1 equals to V2 over T2. And then keep in mind that in this case, my volume is in whatever units, just remember they must be the same, but my temperature must be in Kelvin. We're not allowed to change that. So the temperature comes in degrees Celsius, convert to Kelvin. Fahrenheit, convert to Kelvin. Kelvin, you solve like that. That's all for Charles' law. Next up, the pressure law. As you can see there again, pressure is between pressure and temperature. Now, this law simply indicates that, or it simply states that, the pressure on a gas is directly proportional to the temperature in Kelvin, provided the volume is kept constant. It states again that the pressure is proportional to the temperature as long as the volume is being kept constant. So, just as before, P equals to KT, and therefore K must be P over T, which means it will be something like this. P1 over T1 equals P2 over T2. Let's note that here. I'm remembering that our temperature must be in Kelvin. That's my third gas law. Now, for your general gas equation, the general gas equation simply tells you to combine these first three together. What if nothing is being kept constant? Every single thing is changing. What happens to that situation? If you notice, in my first law, P and V are up. So I can leave that P1 over V1. And if you notice, both V is over T and P is over T. Therefore, T comes down here equals P2 V2 over T2. And this is what is known as the general gas equation. And last but not least, the ideal gas equation. Assuming the gas behaves ideally, you know what ideally means? Perfectly, which we don't really live in a perfect world. But if it was perfect, then PV equals nRT. P is the pressure as before, V is the volume, T is the temperature in Kelvin, but N in that case represents the number of moles, of the gas, while arrow represents something known as the gas constant. And while in every standard exam, like yes, in your JAMB examination, this value will be given to you, that it is, preferable to just keep it memorized to make your solving much faster. That situation, you should know that R equals 8.314 joules per moles per Kelvin. This is the value. But please keep in mind, this only works if your pressure is in Newton per square meter, your volume is in meter cube, your number of moles in moles, and your temperature in Kelvin. If for any reason whatsoever, any of these parameters is in a different unit, then your constant will change. That is why they always give it to you. But if they give you the constant as 8.314 and say, for example, your volume is in cm cube, it is incumbent on you to convert that volume from cm cube to meter cube. That means one other thing to know in this topic is actually the comparisons between different values and how to convert from one unit to another. So quite quickly, let's look at some of those. And you will note, please, let's say for pressure, 101,325 Newton per square meter is actually the same thing as 1 bar. So if the pressure comes in bars, this is how you convert it. You know that 1 bar equals this. And this is also equals to 760 millimeters mercury. These are not quite common units, especially in chemistry. If your pressure comes in millimeters mercury, please note, these are converted from millimeter mercury to Newton per square meter, such that we can have our pressure here in Newton per square meter so that we can use that gas constant. Okay, then please note this is also the same as 101,325 Pascal. Okay, so that is that for pressure. In volume, you must please note that 1 dm cube equals to 1000 cm cube. 1 dm cube is the same thing as 1 liter, but 1 meter cube equals to 1000 dm cube, which means quite simply that 1 meter cube equals 10 raised to power 6 centimeter cube. So, in case you have to convert from cm cube to meter cube, that is what you do. So, yes, this topic simply has the statements of the laws and then the application of those laws in your solving. It's actually quite simple. So, if you've noted the laws and their formulas, then it's time for us to do what we always do in these physics tutorials and open our O3 Schools JAMB app and take in some of these examples. So let's work out some questions on this topic from our O3 Schools JAMB app. Now, I have sourced this question in the app using the search feature, like I mentioned to you. Makes it very easy to be able to write down these questions. We search for the topic you want to look at, say gas laws in your app, and questions about gas laws simply come out. So the O3 Schools app is very useful. Just remember, download it and activate it. Okay. The first question we're looking at is from the year 1997. The year is 1997. Question number 18. And it goes, before starting the journey, the tire pressure of a car was, when starting, the pressure was 3 times 10 raised to power 5 Newton per square meters at 27 degrees Celsius. Now, already you must remember, we do not solve in Celsius. I have to take it straight to Kelvin. We're adding 273, which is 300 Kelvin. Then, at the end of the journey, the pressure rose to 4 times 10 raised to power 5 Newton per square meters. We have to find the temperature at the end of this journey, assuming volume is constant. So if you notice now, pressure and temperature are changing, but volume is being kept constant, which means that automatically I must be dealing with my pressure law. P1 over T1 equals to P2 over T2. My P1 is 3 times 10 to the power 5 over my T1 300 equals to P2 4 times 10 to the power 5 over T2. Now if I cross multiply, this can come up here, T2 comes up here, this multiplies this, 300 times 4 times 10 to the power 5 all over 3 times 10 to the power 5. Now this question is quite simple because remember, JAMB likes giving you easy things to calculate. 10 to the power 5 cancels 10 to the power 5. 3a 1, 3a 100. 100 times 4 is 400 Kelvin. Now this is one of those things where they used to trick you. If you jump to your options, you see that option A is actually 400 degrees Celsius. But remember, we solve in Kelvin, not Celsius. So don't just hurry up and shade 400. Instead, you have to take this value from Kelvin back to Celsius because all my options are in Celsius. So minus 273. And what that gives you is 127 degrees Celsius. Option D. So you have to be careful with these units. Try not to mix them up. Okay. Still on our O3 Schools JAMB app, we're taking a second example. This one is from the year 1999, question 11. A gas at a volume of V0 in a container. The gas has a volume, so the first volume we have is V0 at a pressure P0. First pressure is not P0, and not P0 the biscuit, more like P0 P subscript 0. Okay, is compressed to 1/5 its volume. That means this my V2 is going to be compressed to 1/5 of what was there before. That means 1 over 5 times V0, which as you are aware, V0 will multiply 1 to become V0 over 5. I'm therefore asked, what will be its pressure if temperature is kept constant? Then again, to decide your formula, simply look at your parameters. I have P1 V1, P2 V2, and T is constant, which must mean that I am dealing with, as you are aware, this is Boyle's law. Therefore, I want to find P2 over V2 over V2. Therefore, P2 will be P1, which is P0, times V1, which is V0, divided by V0 over 5. Okay, simple bit of mathematics. This over here, P0 V0, is the same thing as saying divided by V0 over 5. And that should become P0 V0 times, turn them around, I have over V0. That's basic mathematics. P0 cancels V0. So 5 times P0 is 5 P0, implying that my answer is option D. So you see, again, note at what you have, and based on what is constant, you should be able to tell what law you are going to be applying. Question 3. This one is from the year 2001. 2001, question number 19. The pressure of a given mass of a gas changes from 300, it was initially at 300 Newton per square meters, and it changes from 300 to 120, which means it is now at 120. P1 300, P2 120. While the temperature drops from, temperature is dropping from 127 degrees Celsius, 127 degrees Celsius, convert to Kelvin, plus 273. That is 400 Kelvin to minus 73 degrees Celsius. So again, temperature is minus 73 degrees Celsius. Convert to Kelvin. That will be 200 Kelvin. The ratio of the final volume to the initial volume is, final volume is always given by V2 and the initial is given by V1. They want this ratio. Now again, if you look at this is different from the first two. Nothing is being kept constant. Instead, everything is getting used. And remember, the one that uses all parameters was our number 4. the general gas equation. Automatically, P1 V1 over T1 must be equal to P2 V2 over T2. But before putting in my numbers, let me see if I can simplify this. We want to get V2 over V1. So how do I get V1 to come over here? If I divide here by V1, I also divide here by V1. V1 cancels V1. I'm having P1 T1 equals to P2 over T2 times V2 over V1. Therefore, I want to get rid of this guy by bringing it to the left. That's simple to have to do, right? Yes. So how can I do that? Just go to divide both sides by P2 over T2. Divided by P2 over T2. This cancels this here. You know that V2 over V1 equals to P1 over T1 divided by P2 over T2, which, as you are aware, will be P1 over T1 times yes, some assault mathematics, T2 over P2. Therefore, if I simply try to finish it at this small corner here, I then know that finally V2 over V1 must be P1 T2 over P2 T1. Now, mind you, there's no difference in putting in your figures first of all here and trying to solve. I just prefer to actually have an expression for what I want and then put in my figures directly, because this way I'll know that P1 is 300 times T2 is 200 all over P2, which is 120, times T1, which is 400. So double zeros cancel double zeros. 2 here 1, 2 here 2. 0 cancels it 1 0. 2 here 1, 2 into 30 is 15. I'm having 15 over 12. Can I still cancel out? Yes. 3 into 12 is 4. 3 into 15 is 5. Nothing else can cancel out. So I know that V2 over V1 must be 5 ratio 4. And if I take my options one more time, that is option D. You see, these questions are very, very simple. Okay, so let's move on, shall we? Now we are going to year 2002. I want to look at question number 27. 2002, question 27. Okay, the question says the pressure of 3 moles. We have 3 moles. Pressure of 3 moles of an ideal gas. As I mentioned ideal gas, and now I'm going to use my ideal gas equation. So I know where I'm going to. An ideal gas at a temperature of 27 degrees Celsius. Convert to Kelvin, that's 300 Kelvin. Okay, having a volume of 10 raised to the power minus 3 meter cube, 10 to the power minus 3 meter cube is what? We want to know what the pressure is. And we are told R equals 8.3 joules per mole per Kelvin. Now, this is one of those reasons why I say, though you have to, it is easier to know the constant, don't skip, don't jump. If you try to jump and solve with 8.314, you might not find the answer in the options. You will get something close to it, obviously, yes, but you not see the exact value because they gave you the constant to use. The approximated constant is 1 decimal place. So in your solving, you should do the same. However, if I look at everything now, they are all in the right units. This is in Kelvin, this is in mole, this is in meter cube, which means that when I solve for pressure, it should come out in Newton per squared meters, SI units. So PV equals to nRT. I want to find P, so over V over V. P equals to nRT over V. N is 3, R is 8.3, and T is 300 over V, which is 10 raised to the power minus 3. So let's open our calculator and do the initial multiplication, the numerator. That will be, okay, my calculator is just getting open now. That's 3 times 8.3 times 300. That'll give you 7470. Now, I don't have another power here with 10 raised to the power anything to divide this. I simply know that as this guy is coming upwards from mathematics, the power is going to change sign. If it was positive, when it comes up, it will have minus. But it's negative, so when it comes up, it's going to be plus 3. If I look at my options, this answer is not there. My options are all in standard form, which implies that my point would have to leave here and go backwards 1, 2, 3 times, meaning I will add 3 over here. 7.47 times 10 raised to the power 6 Newton per squared meters. And that is option D. Now, by some happenstance, by some circumstance, all our options so far have bumped with option D. I would beseech you not to take this as an assumption that any gas loss question you see in your exam will always be option D. Please do not believe that. Don't try that, It's not how it works. Okay. Our next question is purely theoretical. There's no solving necessary. This question is from 2006, question 47. And this one we have been told, in the gas experiment, if the volume of the gas is plotted against the reciprocal of pressure, if the volume is being plotted against the reciprocal, which is 1 over, of pressure, the unit of the slope of the resulting curve is what? And remember, this is going to be, if you are finding slope of v versus 1 over p, simply the same thing as saying v over 1 over p. And just show us that solving here. V divided by 1 over p will become v times, or if I write it out first, v divided by 1 over p becomes v times p over 1, which is basically pv. And that means that's your slope, right? And remember, when you said pv, that should take your mind to Boyle's law. And we stated that Boyle's law was a statement of the work done in the system, which means in my options, A, power, no, B, work, yes. My slope is actually the work being done. So my answer is option B. You see, this is one of those questions where the solving is not there, but you just have to wrap your hand a little bit of your head around a little bit of a logic, and you get your answer. Okay, the next question is from the year 2007, number 33. It's also related to what we just did, by the way. This one says, which of the following gas laws is equivalent to work done? We just stated the answer just now in number 5. A, pressure law, no. B, Van der Waals law, no. C, Boyle's law, yes. D, Charles' law, no. Work is pressure times volume. So again, my answer is Boyle's law, but now it is option C. So just keep the logic going. That's all you need. Our next question, this one now, proper calculation. From the year 2008, number 21. 2008, number 21 on our O3 Schools JAMB app. We're told a sealed flask contains 300 cm cube of oxygen, 300 cm cube of A, rather not A, at 27 degrees Celsius. So this must be V1, and this temperature must be T1. Again, at 273 300 Kelvin. Okay, and is heated to 35 degrees Celsius. Becomes 35 degrees Celsius. At 273 again. 273 plus 35 is going to be 308 Kelvin. At constant pressure, we are having volume and temperature changing at constant pressure. That must be Charles' law. The new volume is what? I want to find V2. Just remember your formula for Charles' law. V1 over T1 equals V2 over T2. And if I cross multiply, V2 must be equals to V1 times T2 over T1. What's my V1? My V1 is 300. What's my T2? My T2 is 308. And my T1 is 300 as well. Which means all I simply have to do is divide. And this gives us 308 cm cube. All right. Now, funny enough, when we look at our options, our answer is not there. This is one of those times where you solve a question and you'll be small, you just decide, okay, the question is wrong, should anything and go. No. The best thing is to actually read your question again and see if you might have made any mistake in your solving. I read my question again. I realized that my question starts with a sealed flask contains 600 cm cube of air. Rather than 600, Having 300 here, you see, that was the reason why we made a mistake. Our answer should have been there. Therefore, if I correct this 300 to 600, then I used 300 to solve here. That means I must put 600 here, and here is 300. How does that affect my solving? Two zeros cancel two zeros. 3 here is 1, and 3 here is 2. You see? So I should be having 2 in my numerator here. And when 2 multiplies 308, I get 616 cm cube. And is that in my options? Yes. Option D. You see, this is why I said do not panic when you get the wrong answer. Simply read your question again and try to do a bit of analysis and try and see where you might have made a mistake at. Okay. The next question we are looking at now is from the year 2010. We are all the way up to 2010, and this is number 42 of that year. Okay, this one says the pressure of 1 mole of an ideal gas. Again, once we are dealing with ideal gas, we know what to do. We don't need to put in all those numbers like P1 or P2. No, we know we are using PV plus nRT. So we're told pressure of 1 mole, meaning N is 1, of an ideal gas of volume V is 10⁻⁻² meter cube, okay, at a temperature of 27 degrees Celsius. We've done this so many times, I know automatically, once I add 273, this must be 300 Kelvin. Is what? Okay, then as usual, we told molar gas constant R equals 8.3 joules per mole per Kelvin. So we want to find the pressure. PV equals nRT, and just like we did right here, because it's almost the same thing. P equals to nRT over V. So what will my N be? My N is 1, R is 8.3, and T is 300. All over V, 10⁻⁻². So with my calculator, I have to do 8.3 times 300. That is going to be 2490. Then 10⁻⁻² comes up, and the minus turns to plus 10⁻². Now if I look at my options again, they are in standard form. So how do I get this to standard form? Points from here is going to move 1, 2, 3. Because it's moving 3 times, I add 3 here. That's going to be 2.49 times 10 to the power 5 Newton per squared meter. And that is option C. So you see, the solvings are quite simple. Okay. One more theoretical question. This one is from the year 2011, question number 19. If the volume of a gas increases steadily as the temperature increases at constant pressure, there is volume and temperature while pressure is being constant. What law is that? All you have to remember is that the only law that has pressure constant while volume and temperature are increasing is Charles' law. My answer is option A, Charles' law. That's the law dealing with volume and temperature. Okay, and okay, see, there are many other questions. Let's just take 1 or 2 more, and we shall call it quits for gas laws. Because I believe, as we've been seeing the solving so far, we must understand the topic. Okay, this will be question number 8. And for this one, 2000 cm cube of a gas. Let's start with the volume. 2000 cm cube of a gas is collected at 27 degrees Celsius. Temperature is 27 degrees Celsius. And if I add 273, this is 300 Kelvin. And 700 millimeters mercury. And the pressure is 700 millimeters mercury. What is the volume of the gas at standard temperature and pressure? What's the volume of this gas at standard temperature and pressure? Now keep in mind, standard temperature and pressure is commonly referred to as STP. If you are solving a question where they tell you what would be the volume, yes, we're looking for volume, what would be the volume at STP, all you simply have to do is simply note that there's a standard temperature and pressure which they like you to use. And what are those values? Please note. Your standard pressure, which will be our P2, is 760 millimeters mercury. And your standard temperature, which you want you to use, is 273 Kelvin. This is standard pressure and standard temperature. They never tell you at STP, just know this is the pressure they imply and this is the temperature they are also implying. So once I know this, I can solve for the new volume V2. Because since I have pressure, temperature, and volume changing, I am going to use my general gas equation. P1 V1 over T1 plus P2 V2 over T2. Let's put in our numbers. P1 is 700, V1 is 2000 over T1, which is 300, equals to P2 760, V2 is unknown, and T2 is 273. Okay, let's do multiplication and divisions for each side. If I put my calculator, I'll start off by saying 700 times 2000 divided by 300. That gives 466.6667. That's an approximation. Then on the other side, I'm going to be having 760 divided by 273. That is 2.78388. Also, this approximation. Then V2 is here. So, divided by this, 388, and divided by this. Now, V2 must be equal to, let's divide 466.6667 divided by 2.78388. My answer is 1676.3175 cm cube. If I take a look at my options have been approximated to just one decimal place. So obviously 1676 point, just the first number, 3 cm cube. And that is option C. So again, in case you're having difficulties when you try this question, if you have tried it before, just know that standard temperature and pressure are as follows. Standard pressure 760 millimeters mercury. Standard temperature 273 Kelvin. Okay, and we have just two more questions, and we shall call gas laws quits. So we can solve the round number of 10. So for the ninth one, example 9, we're told a gas at a pressure of 10 to the power 5 Newton per square meters expands from 0.6 meter cube to 1.2 meter cube. 1.2 meter cube at constant temperature. We have to find the work done. Now, if you recall, work done is a statement of Boyle's law, and in Boyle's law, I believe I stated it clearly. A work done is equals to P change in volume. Pressure times the change in volume. As I have one pressure now, 10 to the power 5. What's the change in volume? V2 minus V1. 1.2 minus 0.6. That gives me 10 to the power 5 times 0.6. But my options are in standard form. How do I do that? I'm going to move this point forward once and subtract 1 from here. That will be 6 times 10 raised to the power 5 minus 1, 4 joules. And that is my answer, option E. See, this is how the laws work. And for our very last question, question 10, this is from 2014, number 21. Please note this last one was from 2013, number 8. And if I didn't say this, this was from 2012, number 21. So for this last one, we are told the equation P raised to the power A, V raised to the power B, T raised to the power C equals to constant reduces to Charles' law if. How can this give me Charles' law? Like remember, Charles law, how do you get your constant? In Charles law, V over T equals to constant K. If I try to express this in standard form, if my T comes up, that becomes 3 squared minus 1 equals to K. Therefore, I know my V is positive 1, my T is negative 1. Therefore, I'm just going to solve it here. Therefore, my B, which is for volume, must be 1, and C must be minus 1. So even if you don't know how to finish solving, as long as you know B is 1 and C is minus 1, your answer must be B, option B, because that is the only one that has B as 1 and C as minus 1. But then, how do you get your A? You should simply remember, is there pressure in Charles law at all? No. How can I make this pressure go away? By making it go to power of 0. Because then to the power 0 becomes 1. So you see, my answer is A is 0, B is 1, and C is minus 1, which is our answer for Charles law, and that is option B. And with that, we've come to an end of this class on gas laws. I want to remind you, all 3 schools JAMB app. Download and activate. Activation is 2005 naira only. You can trust our activation, it always works. Very, very simple process, and the steps are very easy. Your app gets activated once you complete your payment. So this is everything we have to do in gas laws. So get more tutorials, more videos explaining various topics running across different subjects. Please subscribe to this channel, and you can drop your comments and like these videos. Thank you very much for watching. My name is Athanasius.